G'day everyone. So in this one we're going to be looking at an application question of growth and exponentials when we've been given an equation and we need to work around the equation given. So here we've got 5 kilograms of sugar is gradually dissolved in a vat of water. After T hours, the amount of sugar in kilograms undissolved sugar remaining is given by S is equal to 5 times 10 to the negative KT. Written that out again just in case you couldn't see the KT. So first we need to calculate K. So this could be a constant that's related here that applies to it. When S is 3.2 and T is equal to 2. So they might have measured at some point and they want to work out a model to represent this equation here. So we've got S is 3.2, T is equal to 2, and then we're going to be left with K, and we need to solve this. So substitute these values in. So negative K times 2. So we substitute these values in now. So what we need to do now is break this down so we can get rid of this times 5, so we can divide both sides by 5. So 3.2 over divided by 5 is equal to 0.64 is equal to 10, 2. And I'm just going to say negative 2k. So just rearranging it so it looks a little bit better. So now we've got this and we've got our exponential looking like this. Hopefully you realize you can convert this to a logarithm. So here this will convert to log 10. So our base is there of 0.64. And this is going to equal negative 2k. So to find k, we need to divide log 10.64 by negative 2. Okay, and that will find our k value. So here, this will end up being a value of, and you'll put it in your calculator, and you'll get a value of around 0.09691. Okay, I think there's a few more decimal points there. So that's the value that you do end up coming out with. So now, that's part A. We've found our k value. Okay, yet again, if you want to deal with the exact value in your calculations, you make sure that you use this value in your calculator. Okay, so you can type that in, it will give you an exact value. So just be wary of that with calculations, because if you approximate early, so in part B, when we use k, it would be good to use this value as an exact, so your answer will be exact or as accurate as it can be. I am going to use the second one just for ease of explanation and writing it out, because if I'm writing out that previous one, it will take me a very long time and look very messy. Okay, but you have functions on your calculators where you can copy and paste, so it's just as easy nearly to use that. So with B, we need at what time will 1 kilo of sugar be remaining? So we've got our value for k now, which is down here. So now we need to figure out a value for time when there's only 1 kilo of sugar left. So this, we've got 1. We're going to have 1 is equal to 5 times 10 to the negative, and I'm just going to put our k value of 0.09691 t. Okay, so we've got this value here. So yet again, we can work it out just like this. You can use the change of base theory as well to work it out with logarithms. You can put this as solve in your calculator as well, just like this, and it'll come out with an answer. But I'll show you a few steps where you can just break it down further if you need to. So first, we just divide both sides by 5. We got negative 691t. Okay, so we've got this here, and now we can actually break this out in a logarithm as well. So this becomes log 10 1 over 5, and this is going to equal your exponent here. So this is going to equal your negative. So 6.9691 times t. And then it's just like our last one. To work out t, it's equal to log 10 1 over 5 over negative 0.09691, or your k value. Okay, so yet again, if you do have your cas, you can just put solve and then solve for t and put this into your calculator though, and show that as you're working out. So that's very acceptable way of doing it, but it's also good just to understand how to rearrange it and get to t manually. Okay, so this ends up being an answer, and hopefully you go along with testing it, of 7.21257. So I'm just going to say after 7. So this is just answering our question. What time will 1 kilo of sugar? We weren't given a start time, so I'm just going to say after 7.21 hours. Okay, it's always good to answer a worded question with words. Okay, so make sure that you do that. So hopefully this helps with breaking these down. Yet again, remember you can use your cas and your solve function in these. So you can do that, so feel free to use that way. Alright, so good luck.